Welcome to EDU World Space.
For this problem, we have a convex glass rod that is given by this blue thing here on the right side, and the vertex is this point here, and the black line is the optic axis. And we're told that on the left side there's air, so there's basically air surrounding this glass rod, and the glass rod has an index of refraction, which I labeled as NB of 1.6, and as you know, air has an index of refraction that's equal to 1, and I call that NA. And this problem has three parts. In the first part, we're asked to find, basically for all three parts, we're asked to find what the image is if the distance where the object is located is at A, B, or C, where in part A, if the object is at infinity, we have to find what the image is that corresponds to that, and so on for B and C for their particular numbers. So let's go ahead and write down the equation that we're going to use. And this is going to be equation 34.11. And that says that NA over S plus NB over S prime is equal to NB minus NA divided by R, where R is a radius of curvature. And we're given the radius of curvature in this problem is that it's 3 centimeters. So this is going to be the main equation that we use in parts A, B, and C. So let's go ahead and directly substitute for part A that S is infinity, and we're going to put in the numbers for NA, NB, and R immediately. So NA is 1, S we're told is infinity, and NB is 1.6. We don't know S prime, and NB minus NA is 1.6 minus 1 divided by 3 centimeters. So if you're dividing 1 by infinity, then you get 0 because you're dividing 1 by a very, very large number. So that goes to 0. And so you're just left with a very simple equation, which is 1.6 over S prime is equal to 0.6 over 3 centimeters. And then you do a little bit of rearranging, and you find that S primed is equal to 3 centimeters over 0.6 multiplied by 1.6. So let me just put a multiplication sign there. And this gives us that S primed is equal to 8 centimeters. So let's move on to parts B and C. Let me rewrite the main equation that we'll be using. So it's NA over S plus NB over S prime is equal to NB minus NA divided by R. And now I will actually rearrange this whole equation so that I have S prime isolated by itself. So I have NB over S prime. If I subtract NA over S from both sides, then that's equal to NB minus NA over R minus NA over S. And at this point, I can I could basically put this side over a common denominator. So then I have NB over S prime is equal to S times NB minus NA over SR, and we subtract from that R times NA over SR. So we can solve for s prime. So s prime is given by s r n b divided by s n b minus n a minus r times n a. Okay, so this is what we'll use. So this is just rearranging equation 34.11 so that we can isolate s prime. So all we have to do now is just plug in the numbers. So b, we're told, we're given that s is equal to 12 centimeters. So we literally just plug in the numbers here. So 12 centimeters for s. Recall that r is 3 centimeters and b is 1.6. S again, 12 centimeters. NB minus NA is 1.6 minus 1 minus 3 centimeters, which is R, and minus NA, which is 1. And you can just plug this into your calculator and you'll find that that is 13.71 centimeters for S prime. Now we'll do exactly the same thing. We'll just repeat the same kind of thing, except that now we replace S with 2 centimeters, which is what we're given for part C. And then we'll find that S primed is 2 centimeters times 3 centimeters times 1.6 divided by 2 centimeters. 1.6 minus 1 minus 3 centimeters times 1. And this gives us negative 5.33 centimeters.